Okay, let's just first address the elephant in the room. I know it doesn't look like a conventional typewriter, and trust me, there's a very good reason for this, and you'll understand what I mean in a couple of minutes, but I can assure you that this is an actual working typewriter that you can 3D print. I'm going to show you how it works, and we're also going to test it out, but it would be weird to do that without any context, so let's start at the very beginning. It was a rainy November night, and I was watching a feature documentary about Harambe's assassination, and suddenly I found myself looking at this one video in my sidebar recommendations, and I still don't know what happened. Maybe it was my Cheeto dust encrusted fingers that slipped, we'll never know, but I clicked on the video and that led me down a rabbit hole of typewriter related content on YouTube. I was so fascinated by the idea of having a mechanical thing that can write words on paper that I started thinking about the possibility of making a 3D printable version, which led to some more research and talking to friends who own a typewriter, and this is essentially what the basic mechanism boils down to. There is a type bar which has the mirror image of the letter you want to type on one end, and the other end is mechanically linked to a key. Once you press the key, the type bar swings towards the paper and leaves an imprint of the letter you wanted to type. Oh, by the way, in a real typewriter, there would be an ink ribbon like this one between the type bar and the paper. And let's just talk about ink for a second because this thing is a nightmare to deal with. Even if you're really careful while working with it, your hands are eventually going to end up looking like you just committed a violent hate crime against Squidward. But thankfully, we're not going to be using ink ribbons for our typewriter. Instead, we're going to use carbon paper because it's cheap, easy to handle, and available everywhere. If you live in the 1980s. Okay, I can't be the only one who, as a child, thought that this was what they meant by carbon footprint, right? Right? The next thing we need to design is a mechanism that will move the paper by one space with every key press, and in real typewriters, this functionality is achieved by using a spring-powered mechanism called an escapement. Escapements are really complicated and, more importantly, really flimsy, so I thought I'd make my own more robust version of the same thing, and this is what it looks like. So instead of being spring powered, this is going to be powered by your fingers. Every time you press a key, this part will move up and the rack will move forward by one space. But when you lift your finger, the rack doesn't move back to its original position because that would be insane. For those who are interested, this is just a rack and pinion mechanism coupled with a ratchet. Okay, the two main mechanisms are done. We will add a holder for the carbon paper later so that we can see what we're actually typing, but at this point, we can just start working on the prototype for the typewriter's body, and here's what it looks like. This semicircle is where all of the type bars will rest, and I've linked the type bars with the escapement through these beans. Sorry, I think that's a typo. I meant these beams. When you press a key, this beam contraption thingy will raise the pusher attached to the escapement, moving the paper carriage by one space. At least that's what was supposed to happen. So some of you might remember that I posted this exact prototype on my channel in November, and then just like an involuntary moan during a job interview, I conveniently pretended like it never happened. Well, here's why. Throughout the history of this channel, I've tried to make 3D printable versions of real things, and more often than not, they work out just fine because the material properties of 3D printing filament never really get tested to their limit. But in case of typewriters, we need certain parts to be very rigid. Take this contraption for example. If you look closely, the beams are all H-shaped, which is supposed to be the least bendy cross-section for a load-bearing beam. And also I've added these ribs for extra support, but even after all that, they're bendier than a Japanese salaryman at a business meeting. So as long as you press a key around the center of the keyboard, it's gonna work fine. But as soon as you move towards the edges of the keyboard, the beams flex a lot more, and because of that, this pusher doesn't move up properly and the escapement stops working. But that's not all, because God forbid if my whole project doesn't implode on itself a week before my upload deadline. Remember how in real typewriters the escapement is spring powered and not human powered like my mechanism? Well, turns out there's a reason for that. Leaving a legible imprint on paper takes a considerable amount of force, and on top of that, if we add the force required to make our escapement work, well, that's just too much effort for one single key press. And since you guys know that I'm built less like Dwayne "The Rock" Johnson and more like Dwayne "The Rocks" Johnson, this is a huge issue for me. At this point, I had no choice but to abandon this project, and I was really sad about it. Oh, fuck you, Bob, you overachieving claymation asshole. But then I got my shit together, drank some expired Yakult, dry heaved in the toilet for 3 hours, then banged out another low effort Beyblade video in about 2 weeks, which became my most watched video ever. I hate my life. Then for the next 2 months I kind of forgot about this project until one day when I was watching a technology connections video about old phones, something just clicked. And we're going to talk about that, and I'm also going to tell you about how this shitty Instagram game saved this entire project. No, unfortunately, I'm not kidding. But before we do that, I want to thank my sponsor for this video, PCBWay. If you guys want to build something, whether it's a robotics project or a mechanical one like this one, or even if it's something more industrial like CNC or 3D printing, whatever you could possibly need, these guys can help. They've helped me with my past projects, and their services are extremely affordable for the quality that you're getting with a quick turnaround. So it's a total no-brainer if you're starting a build project of your own. Check them out at the link in the description. Now back to the video. Okay, I'll get straight to the point. It's rotary phones. That was my inspiration for the new design, and let me explain why. So in rotary phones, the main action, which is dialing a number, happens at a fixed place, which is where your finger stops when you input a number. So if I apply the same idea to a typewriter, we can eliminate a lot of moving parts and completely get rid of the issues caused by the filament being too bendy. Here's what I have in mind. So this free spinning rotor would hold 26 hot swappable keys, and you can only press a key when it's positioned directly above a slot in the base plate. Once you press a key, the paper carriage will move under the type slug, get an imprint of the letter associated with the key, and then move back to its original spot once you release the key. Now the reason we're doing this is because ideally you want to be able to see what you're typing. In traditional typewriters, it's the ribbon that moves, but since in our case the type slugs directly cover the paper, we need to move the paper carriage instead. Now the question remains, how do we move the paper carriage? No, not like that. Well, my first idea was to use a wedge like this one with some rubber bands. And while in a frictionless world it would have worked fine, but in reality this mechanism jams way too much. And every key press feels like biting into a raw potato, which if you've never done that leaves you with a strong sense of shame and is not a great tactile feeling overall. So instead we're going to use a rack and pinion mechanism. Here's how it works. You press a key which moves this rack, which rotates the pinion, which moves this rack, and attached to this rack is the paper carriage. Add a rubber band to the setup and we're done. It works great. Now after making a few adjustments and attaching the rotor to it, here's what it looks like. As you can see, there's a 1-to-1 displacement ratio between the key and the paper carriage, which might seem great on paper, but unfortunately there's a new problem that we need to fix. So for some reason, if the paper carriage and the type slug stop moving at the exact same moment, the whole thing ends up looking like Papa Smurf's undies during the 2020 toilet paper crisis, which is not ideal. To fix this, we need to make it so that the paper carriage comes to a stop a few millimeters before the type slug and then starts moving again after the type slug has been lifted. We kinda need a mechanical delay switch, and honestly it took me a good day or two to figure this out, but the solution was surprisingly simple. We need to just break the paper carriage down into two parts. The top part, which would have the paper on it, is slightly longer than the bottom part and is attached to it with a rubber band. So when we press a key, the top and bottom parts move together until the top part stops, but then the bottom part keeps moving for an extra few millimeters until the type slug reaches the paper and leaves a relatively smear-free imprint, which makes me very happy, as you can probably tell by my facial expressions. Now that that part is done, we can start working on the escapement mechanism to move the paper carriage by one space with every key press. And at first I really wanted to recycle my old mechanism because frankly I put a lot of time into it, but then again I also don't want to run into the same issues as last time, so I think I'm gonna have to make an actual spring powered escapement this time. Okay, I've researched a ton about escapements from typewriters to Swiss watches, and everything that I've found so far seems too complicated with too many parts, and I feel like this is not gonna work for us. Because my goal with this typewriter was to make it simple enough that you could easily assemble it at home without your living room feeling like a Bangladeshi sweatshop. At this point, I had already invested more than a couple of months into this project, and it really seemed like I was being irrational by trying to fix it again and again. I was also running out of money, and it seemed like my only real option was to abandon any sense of shame and make another Beyblade video. But then one evening while I was scrolling through Instagram, consuming my daily dose of breastfeeding videos and racism, I got an ad for this really crappy game where you need to navigate through disc-shaped levels. I mean, I don't need to explain this, you've probably seen this garbage a million times, but this gave me an idea for a new kind of escapement. Okay, so here's my new design. Every time you type a letter, the cylinder will rotate and the paper carriage will move left by one space. The paper carriage is connected by a rubber band to the left side of the assembly, and this protruding bit latches onto the cylinder. The cylinder has two grooves on each level, and as soon as you turn it by 90 degrees, this nub slides through the groove and stops at the next level. Now, while I know that this thing looks like something Megatron would have used in college to explore his sexuality, I think it's actually pretty clever because it makes the spacing independent of any fixed gear ratios. So you can modify the spacing and character count by just changing the size and number of levels. But now you might be thinking, how are we going to turn the cylinder by exactly 90 degrees with every key press? Well, here's how. So these propeller looking things connect to the ends of the cylinder, and as the carriage assembly moves back and forth, these prongs interact with these stationary horns on either side of the typewriter, turning the cylinder in only one direction, thus moving the paper carriage forward with each key press. Oh, I almost forgot, I'm giving away another Bamboo Lab A1 Mini with this video. Holy mother of God, these things used to be like $180 like a couple of weeks ago. What the actual fuck? Well, maybe I should have checked before promising a giveaway, but in any case, I'll just pick a random subscriber from the comment section a month from the release date of this video. Anyway, we're not quite done yet because we've got another problem to solve, and it's supposed to be the easiest one of them all. We just need to add a little spring-loaded holder for the carbon paper. And I did that, and it turns out you can only get maybe 3 or 4 letters out of a single spot of carbon paper. After that, it just runs out of ink. Great, now we need to somehow figure out a way to move the carbon paper along with the paper carriage so that there's a fresh spot for every subsequent key press, but the paper carriage is moving back and forth. So how the fuck am I supposed to link it with a stationary carbon paper holder? Well, here's what I did. I made this arm that allows the carriage to move freely, but it also couples this strip of carbon paper with the paper carriage, so it moves forward after every key press, thus making sure that there's an unused bit of carbon paper available for the next key press. Okay, so we're done with everything. Now we just need to make it look less like something that would get you involuntarily fisted at an airport, and then we can print the final thing. Here's what it looks like. I think it came out pretty good. Now it's time to test it out. Okay, it works, but in all honesty, this is just a proof of concept, so to speak, and there are still a lot of things that can be added to make it better, and because of that, this time I'm also including the step files with the 3D print files and instructions for this project so that you can add new fonts and symbols, play around with spacing, add more keys, etc. And everything is available on both my Gumroad and my Patreon. Links in the description. Also, if you want to make something simpler like any of my past projects, you can find those on my Gumroad as well. And a special thanks to my Patreon members for their continued support. It genuinely means a lot to me. I promise I'll be more active from now on, and I guess that's it. I'm gonna take a couple of days off now, and then the next video is probably gonna be another Transformers video, so consider sticking around for that. Like and subscribe if you feel like it. Consider watching this video next, and I'll see you later. Bye.
You and I, we are so random. You bring the darkness to the light, split the atom. I ignore the fact that this will never last.